Hi, my name is Nirav Shah. I'm a cloud software architect at Dell, and I have with me.
Oh, Scott Ramsey from Dell Technologies in Austin, Texas.
Well, thank you for joining us. I see a large crowd. I really appreciate you taking the time. And those guys online, thank you for spending half an hour with us. Today, we're going to talk about lifecycle management at scale. Um, well, coming to OCP, before I got here, um, before we did this presentation, we were thinking we'll have to walk through a few minutes of why do we need to do lifecycle management at scale. But walking in here, looking through all the keynotes, listening to our leaders, I think one thing that is really apparent is we can predict the future. The future is there's going to be a multi-digit CAGR growth in data centers. And what does that mean for us? It means today we have tens of thousands of hundreds of thousands of systems in a data center. And that's going to be a norm going forward. It's going to be the predominant use case going forward. We don't have to justify this. There are lots of data that over the course of last 2 days, people have presented. And it is something that we all know now. So what do we do about it? How do we address that? This presentation has had close collaboration across different CSPs, different vendor providers, and different industry leaders. This is a joint presentation. We are here, but I think it's a work of across different people. So I want to acknowledge all these people. Before we start, thank you, everyone. Yeah, go ahead.
Do you want to talk about the overview?
Yeah, so if you're not familiar with CSM, if you have not seen the previous video, we as work group, we focus on, as I said before, cloud service manageability at scale. Our goal is to address cloud definitions and call out challenges with respect to hyperscale manageability.
Hyperscale. So we have data centers. We have thousands and thousands of systems in those data centers. Apologies for folks that work on network switches and other infrastructure. They're there, but they're in there too. But like some of the presentation we just talked about, there's a lot of data information being collected. We talked a little bit, sort of focused on like failure data, but it's not just failure data. There's inventory information. There's information about when a system was deployed. There's information about software running on the system and how's that software running, performance data. It's all being collected. And it's a lot of data. And it actually takes planning to think about why would I need this data? What am I going to do with the data when I get it? And that's what the life cycle we're going to talk about today. We're going to try to map this to that. But this is a big problem because there's lots of systems. So if you have a bunch of systems and each of them sending a little bit of data, maybe it's not a big problem. But you have lots of systems even sending a little bit of data. There's a lot of data to collect, and you have to get it through back out of the data center, aggregate it somewhere. You got to store it somewhere. You got to process it somewhere. But this makes me think about there's like a physicists talk about what kind of computer does it take to simulate the universe. Well, what kind of computer does it take to simulate the data center? Well, you need another data center, maybe. So yeah, all that information, it's being collected, as we talked earlier on the earlier discussion, in-band and out-of-band, out of the systems. There's some type of aggregation logic. Hopefully we're moving towards machine learning or AI/ML or something fancy. There's not a human sitting there reading this data because, well, that's how I started 20 years ago. But, but we're a little bit more sophisticated, and all that data rolls up into what we're sort of calling this hyperscale data model, where there's a overall structure to this, and the structure is something that everyone in the community can use and leverage to help drive the life cycle of their data center. And not just drive the life cycle of the data center for business operations, which is always important, but also for the tenants of OCP. We want to make sure we've got sustainability and growing the data centers in ways that make sense. And when you make new data centers, you should be looking at the old data center and say, well, this one worked this way, and this is not so great, so let's change it for the future and make things better. Impact. That's the one. All right. So this is sort of an idea that we threw around, a sort of a pyramid structure of we have top of the data center and the racks, and then below inside the racks there's systems. Apologies again, there's network switches and stuff in there. And at the bottom there's components. And if you think about the operations of a data center and operations of even the systems and components within them, there's different questions that come up at different times. So this is why we sort of came up with a structure, because sometimes you might be looking at, say, power data, power consumption at a rack level. Maybe it's at a system level. But then at times, like we talked about earlier, you need to go find a system that has a bad firmware in it, and you want to go find that and block it off or upgrade it or whatever. So different types at different points in time as we go through this life cycle, we'll see where different pieces of data are used. And it doesn't mean that this is perfect. It's just a starting point, and we think there's a structure that's both vertical, horizontal. You want to go to the next one?
Thanks. Oh. Oops, sorry. No worries. Yeah. So just to recap, this is something that we presented last year at CSM. What we did is we took one use case. We started small. We focused on a single use case, which is telemetry, and we looked at it and we said, how do I go about aggregating telemetry that I collect across devices, across components, across systems? And we came up with this tiering model, and we said, what telemetry is collected and how it's viewed can be different at different stages of aggregation. So we have various levels of aggregation here, system level, chassis level, and then the entire data center. And there are some security implications across the board as well. So this is something we presented already last year. Just want to recap it. So from what we presented last year, we wanted to zoom out. We wanted to, how do we go about solving this problem, right? About the eons of data that we collect, we have to structure it, we have to aggregate it, and we have to make sense of it. How do we do that? So the best idea that we could come up with is, we are all architects. We like to break a tough problem into smaller pieces and then solve it in smaller pieces. So that's what this slide is trying to do, is we took the OCP's lifecycle process and we mapped it to the hyperscale data centers, and we said, these are the factors that we need to take into consideration. And yes, OCP has done a tremendous amount of work already that we can borrow and we can build on, right? So some of the things where when you're setting up a data center, you want to do it in a sustainable way. I think a lot of presentation over the last 2 days and in previous conferences have touched upon this. There are certain aspects when it comes to hyperscale. I heard the keynote yesterday about talking about needing a nuclear power plant to just run a data center. That's radical, right? But we will need that. And so how do we go about doing that? So we have a lot of standards bodies that are already working on it. And as CSM, we go about contributing to those and add our own flavor with respect to hyperscale cloud computing and influence those. We talked about hardware fault management and hardware management in general. That's an area that's already evolved. And as CSM, we want to look at what can we help in that area and bring about additional problems that we can solve, additional opportunities that we can identify. At the same time, there are areas, conformity, orchestration, software management, inventory management. These are new areas. These are areas that have not been focused upon until now. And with good reason, right? When you're managing an enterprise system, you probably don't need to handle these things. But when it comes to scale, when you're talking about tens of thousands of systems or hundreds of thousands of systems, and even actually yesterday somebody was talking about millions of systems, how do you do this? And when all of these systems are heterogeneous, you have to be able to collect that data, aggregate that data, and manage it. You probably need a data center for it as well, right? So now you have a chicken and egg problem, right? So that's what that's what we want to do here.
No, actually, you get some data center space in someone else's data center, and then you just put your data in.
You pay somebody else to do it.
Yeah.
That's perfect. So we want to go about this. We want to take a certain set of these things. We want to show you the value of doing this, and and that's what we want to focus on the next few slides. Thanks. Yeah. So let's zoom in. Let's take a few examples. And strictly speaking, these are examples, and we want to just show the value here. Let's take a system, and it's aggregated through different levels and different stages of the life cycle. We want to focus on some of the information that already exists. Fault management already has a pretty structured data representation. Inventory management, utilization. You must have heard a talk yesterday about PUEs, how the definition needs to evolve when we talk about hyperscaling. So that's a great example of something that needs evolution, and OCP as a standard is working with that, and we are helping with that. There is inventory management, which is where some of the health information will be used to kind of decide whether do I need more inventory? How do you make that decision? We do that today, right? CSPs work hard, data center operators work hard on collecting this information. We want to do this in a more structured way, in a sense that we want to make it happen in a way that we can share that information, good practices across different industries, and tread that fine line of making it happen in a way that it's conforming to a particular standard, and at the same time, it's helping with innovation. So that's the fine line that we are trying to accomplish here.
Well, before we jump over to you, I just want to highlight that it helps me when we think about the data and like as a hardware person, and it's like, oh man, we have to collect every bit and save every bit, and we have to store every bit, and we have to have it forever, and sorry, security, but yeah, we're gonna have all that. Anyway, the thing is, it really helps to think about how this data maps into the life cycle, because actually that life cycle makes decisions, and the life cycle is, like I said, driven by operations. And if you think about it in that framework, then you can sort of narrow down what you need to collect and why you're collecting it and how long you keep it and what you do with it. So that's why we drew that slide that way. You ready to talk about the model?
Sure, yeah.
Here we go.
Well, I think this is the slide that we wanted to spend most time on. Again, this is an example data model. There are things that already exist, and we want to reuse those. But there are things that will help overall represent the entire data structure and a data center. So starting from a device or a system, we want to build what kind of information would we want to aggregate over time, right? Well, there will be a type, which is self-explanatory. We want something that is identified. It's just an identifier. What that does is it helps you uniquely identify any component on your data center. It doesn't have to be specific to a GPU. It doesn't have to be specific to an Ethernet card. It's a unique ID. More information is needed about that. What kind of firmware version is it running? What kind of hardware version is it running? And that could help you represent anything and everything on your system or on your data center. Moving on to hardware errors, we have spent quite a bit of time. There are standards that already exist. We were just talking about CPER records. We can use those standards. We can build on top of those and build a unique representation of what a hardware error is or what a software error is. And this is where we'll work with fault management team and others to kind of build that. Talking about health, health is an important factor in deciding whether I spare something or not, or whether we bring some new hardware, and that directly impacts your inventory. So what we want to do is we want to take the errors, collate them, represent them as a set of errors. Every device, every component, every system out there will have a threshold for how much it can handle before it has to be end-of-lifed or recycled. And we want to represent that in a very unified way. And it can be done without even knowing what the device is or without going into the specifics of that device. So that's the goal here, is to not get bogged down with the specifics of certain devices, but have some data represented in a way that helps the overall data center. So a few things that we're going to call out is what kind of correctable errors have you already seen? What kind of uncorrectable errors have you seen? What is the threshold, and what are the error policies that we have? And these will help decide the health of the overall data center when it's aggregated. Moving on to utilization, I took an example of PUE that was specific to power utilization. But I think compute utilization, power utilization, thinking of it as separate entities or as a collective entity. What you want to find out is what is your average utilization? Is it right approximately where you want it to be? Is it lower? Is it more? Are you overloaded? These are the kind of decisions that you want to make based on this data. We want to have an average uptime, average utilization, average uptime since the reset, and so on and so forth. And the last but not the least, we want to talk about certification. It's one of the most important things when it comes to data center, and it's the most overlooked things. And sorry, I have it at the end, but I wanted to make sure it's there. When it comes to certification, we want to make sure what we have out there is certified. And certification is an ongoing process. It doesn't end when a data center is onboarded and deployed. It has to be something that is renewed and over time taken care of. So we want to make sure that's represented as well. So this is the overall model that we want to go about working with different work streams to kind of chase down. And that's something that we'll be working over the next year or so. In summary, want to call out, data centers are growing. I mean, there's nothing we can do about it. Actually, we have to embrace it. We need a definition of a hyperscale data center, which we kind of took the liberty to go about doing today. We want to apply the generic life cycles. That's what we did today. We went through from bottoms up, tops down, and walking through the life cycle of a data center. We said, this is what we need to go chase down. We have identified unique opportunities for standardization. And this is what we want to work towards in the next 1 year or so. And then we presented a case study. So that's pretty much what we wanted to talk about today. And the last slide is pretty much the call to action. If you think this will be helpful, if you think, I think one of the biggest thing that I came out from OCP for me is one of the talks that said, you don't want to standardize for today. It's too late. You want to standardize for tomorrow. You want to standardize for the next 2 or 4 years. And that's what we aim to do. And that's what we need help with. So if you feel like this is something that is interest to you, please join us. And this is how you can go about it. Thank you. Yeah, we can take
Taking questions.
Yeah, about 8 minutes. Go ahead.
You mentioned certification.
Yeah.
Does that include when something's decommissioned as well?
Absolutely. Absolutely. That's part of the inventory management as well. So some of these things are not unique across one thing. And this is just something that we want to collect. And at the same time, I think we do recognize, as a consortium of industries, we do recognize that there is a fine line that we want to walk between standardization and innovation. And we don't want to hamper innovation, but we want to help innovation through standardization. So that's the biggest goal for us. And to answer your specific question, yes. So if you go back to the slide where we talked about the data model, right? Utilization, error, all of these will feed into a decision-making process of when you end of life something. And it's not exclusive. It's not bucketed in that way. But all of it informs it. And that's why that aggregation logic, which might be unique to your specific use case, is very, very important. And that's where data centers have to provide their unique value add. Thank you for that question.
I'll pile on a little bit in that. Yeah, when you decommission, right, you might need a flag. There's inventory part that you're trying to track this stuff down. And you don't have to go, oh, that's fine. Yeah, so if you go back to the, if you're going to decommission equipment and then recycle it, there's certain countries have certain laws. You might need to have that parameter in the system to identify those parts. And so you might want to make sure before you decommission it that this gear goes to a certain processing mechanism, handling whatever is needed for wherever it's at, right? And right now we suspect that that's happening. Maybe it's not being done indirectly or directly, but everyone has the same sort of challenge there. So we could all rally around a data structure and define it and put it in the model, and all the supply base can live off of that and operate off that. So. Anything else?
Go ahead.
Oh, sorry.
Looking at the data model that you presented makes me think a lot about redfish.
Yes.
How has redfish kind of played into this gap that you guys are discussing?
Thank you for that question. I think this is the question we were expecting. Yes. So, yes. Let me repeat the question. How is redfish influencing this data model is the question, right? Yes, redfish is something that we want to go and target. We want to collect this. So we look at this as requirements collection. We want to work across the OCP forums. We want to collect these requirements, and the end goal is to go and feed that into redfish. The idea here is let's, as a community, come together, bring out our uniqueness, put that in a standard BKM, and agree to a standard which we can then go and help work with the MTF to implement it.
Yep. I'd like to add a few more comments on
Go ahead.
some of the reason we were trying to look at the LCM, right? Couple of things really, right? We are really looking, if we have a common life cycle, management, how is it going to be done at a large scale level that OCP can agree on so people can have a common language? That is number one. Number two is we are looking like, we have a lot of OCP projects out there and a lot of work streams going on. We need to understand what they are producing, who's consumer of that data that is produced by the each work stream. If we don't have mapping, we are leaving up to the vendors to figure out what they need to do. At least an agreed mapping, general things, right? The third thing is, as part of their projects, if they can put a life cycle, people can really say, hey, I need to consider before even I purchase a system, right? Maybe I need to look at sustainability, or I need to look at how much power is going to be consumed. So people can make a decision, hey, where are the data is going to go through, so that you can have a mapping of it. Currently, nobody's looking at it. We thought like maybe CSM should take a look at it and create a white paper so that we can educate the community. And out of that, we can also find opportunities. Maybe we can identify where we need to establish an work stream or work to identify and close the gaps. Good.
But thank you for that question. That's a great question. Any more questions? Well, parting thoughts. Do you have any parting thoughts?
No, I think we covered it.
So, anybody from the CFM work group have any thoughts that you would like to add? Panos,
Panos.
of course, come on board. We have time.
I wanted to give an extended answer to this redfish question. I think it was also in the keynote that something we need more of OCP is more conformance and consolidated measurement of, like, let's say on the sustainability aspect, we need more standardized way of measuring the sustainability and the power efficiency factors of the data center so that we can compare across industry and actually race for improving on these subjects, right? So going to the other extreme, redfish is a technology, is a transport and presentation layer that we have chosen to use in the management of systems in other aspects. The premise here is that we don't reinvent the wheel, we don't reinvent standards, and we use what we have to the best of its extent and see if we can extend it for the other use cases like the lifecycle management, right? We may hit a barrier or not, I hope we don't. And we use that as a baseline for designing the interoperability of aspects beyond a single system, beyond just a physical device or not, right? Hopefully we will stay on the semantic layer, that we want to identify the semantics and then use a presentation layer like JSON or DMTF and Redfish and the RESTful interfaces that Redfish supports to implement that. But that's not what the CSM would strictly force anybody to do. I think the CSM role is to define the gap, to define the need for a standard in that direction, and obtain alignment across the industry to go and implement that in a way that suits everybody. Thank you.
Thanks, Manos.
Well said.
Well said. Thank you, everyone. Thank you for the questions.
Thanks.